Okay, so this problem is going to help demonstrate how to calculate the IMA of a bolt or a screw. You will recall from the previous slides and information that the distance to the effort is one rotation of the effort arm, also known as the circumference. So remember, when we're turning a screw or a bolt, we are turning it in a circular pattern, whether we're using our hands or we're using a wrench. So let's start with this problem. So IMA is equal to dE over dr. But dE can be known as circumference. So it can be circumference. And distance to the resistance that the resistance is going to travel is going to be pitch. So the definition on the previous slide told you that the distance to the effort travels is going to be the distance. So if my fingers here are the screw, it is going to be the distance that the wrench travels, where my hand is pushing on the wrench. It's the distance that this effort will travel in a circular pattern. Pitch relates to, as shown on the previous slide, is the distance between this thread and this thread. And the way that we can find pitch, okay, so pitch is equal to 1 over threads per inch. And on a previous slide, it was told to you that the 1/4 represents the width of this part of the screw or bolt. Not this part, not this width, but the width of the actual threaded part of the screw or bolt is 1/4. So that is 1/4 of an inch in diameter. The number we are interested in, however, is this number. This number represents the threads per inch. So TPI here is 20, and pitch is equal to 1 over 20. Okay. Or it's much easier for us to, in our calculator, 0.05. Okay, that's that as a decimal. So then the problem says, well, what if I turn this bolt with an 8-inch long wrench? Okay, so if I turn this bolt with an 8-inch long wrench. So let's see what that looks like a little. So from overhead view, what we would see is a bolt. Just imagine that's a bolt, sorry, and a wrench. Okay, and what it's telling us is that the wrench is 8 inches long. So from basically here to here is 8 inches. Okay, 8 inches. And if you recall also, when using a wrench, like we're going to push down on the wrench on the end of the wrench. So the end of the wrench, when we push down on it, is going to turn in a pattern that looks like a circle, right? It's going to turn in a circular pattern. So the question is, how do I calculate circumference, right? DE is the distance that the effort travels. So one rotation of this bolt, this handle, is going to travel all the way this distance. Okay, so the circumference. And dr is going to be the distance between this thread and this thread, or this thread and this thread. So one rotation of this bolt, means it will go down that far. So the distance the resistance is going to travel is going to be divided by pitch. So in this case, if we back up a little bit, and we have our 8-inch long wrench, and we're going to turn it in a circular pattern. Okay, so what are some of our givens? Well, our given here is we know that the radius is 8 inches, right? When we had that circle drawn, that was 8 inches was the radius of that circle. We also know the TPI is 20, and we know that the pitch is 1/20 or 0.05. The unknown here is IMA. The equation is circumference divided by pitch. When we substitute, well, we don't know the circumference, but we can find it with the radius, right? So we can do 2 times 8, so 2r times pi divided by the pitch, 0.05. Now, let's pause for a second because what's important here is the most common mistake. The most common mistake is that students will do this as the equation, and they'll do circumference divided by this number. This number is TPI. That's not the equation. The equation is circumference divided by pitch. And you must recall that to get pitch is equal to 1 divided by threads per inch. Okay, so make sure that they do not equal each other, that you do not do circumference divided by threads per inch. You do circumference divided by pitch, which is 1/threads per inch. So if we do this problem, we get basically 16 times 3.14 is approximately 50.24 divided by 0.05, and we get approximately 1004.8 as the ideal mechanical advantage.